Okay, good morning, everyone. Okay, today we're gonna keep talking about exponential functions. First, any questions before I get going? Anybody has any question? All right, so I know you're concerned about your exam. The grade will be out probably by tomorrow evening. So you guys will have it will be graded. The solution will be on Brightspace. So tomorrow evening, most probably everything will be for you there. All right, so we're gonna do section, I think it's 13 point, which one? One, no, sorry. I'm confusing with another class. 3.1, 3.2, okay? So exponential function. Let's see what we know and what we're going to learn today. So we're working with exponential functions. Right. First, let us remember that exponential function they have, so let us recall. What is their form? It means how they look like. So their form is a constant a, which was your initial value, times b to the t. So that's how they look like. And a is what we call the initial, and b is what we call the growth factor. That's what an exponential function is. And let us see where they arise. And so I'm going to very quickly remind you how, so the scenario where exponential function arise means how do they arise? And they arise a lot. That's where their importance is. Right, so a very quick review, like, so a scenario one. They arise when, let us say you put money in the bank and the money grow by the same percent, like for a long period of time. Every year it grow by the same percent. Then the growth is an exponential. It means the formula to find the amount of money after every year will follow this pattern. So the scenario number one, suppose at t equal to 0, Joe deposit $5,000 in the bank. Okay, that was the scenario. And the money grew, increased, grew by, let us say, 2% per year for a long period of time. Let us say the growth remained the same for a long period of time. And then find a formula for, so we're going to let f of t be money in the bank after t years. After t years, so that's really how we think. So our question is, what is the formula for f of t? All right, so what is the formula for f of t? So that's really a typical, that's how exponential grow. So f of t is the initial value times b to the t, the growth factor. Now b is 1 plus the growth rate. Since we have a growth here, so the growth rate is 2%, which is 2 over 100, 0.02. It means the function is 5,000, 1.02 to the power t. So that's really how those functions arise. And in pictures, I mean, graphically, what's really going on? Graphically is the following. So the growth here is definitely not linear, because how does the growth work? We start at 5,000. That's really what happened. A year into that, after 1 year, the money grew by 2%. So after 1 year, that's the balance. So that's the time, and this is the money after 2 years. The money grew. By how much it grew by 2% of the 5,000. That's by how much it grew. So 2% of 5,000, we can pick up our calculator. I think it's like $100. So after 1 year, so that's really the growth. It's 5,000 100. So the money grew. Now, a year later, it's going to get again another 2%. But now the 2% is over a larger amount. So now the 2% is going to increase by 2% of the 5,100. So which is, if I pick up my calculator, it's going to be $102. So the growth is definitely not linear. It means we're not, so definitely not linear. We're not growing by the same amount. The first year, 100, but now the money grew 5,100. So now we're going to have a growth over a larger amount, which is 102. And it keeps going. So when we graph, it's definitely, it's going to curve, and that's an exponential. It's going to look like that, the graph. Okay, so that's the piece that how exponential function rode with us. Okay, that's how they come up. Things that grow by the same percent. So money in the bank, it does. Population will do that. A lot of time in infection also grow exponentially. Now, like, unfortunately, what we're dealing with, the COVID-19 at the beginning, it was growing at an exponential form. It was not growing linear. So every time it's increased by more than, every day it was increasing by more than it increased the day before. So it was definitely not a linear growth. At the beginning, the epidemic, we had an exponential growth. Okay, so that's how we studied. That's the part we've learned about it. Now, again, we took another scenario in class where things decreases and the same thing happens. So that's a quick review of what we know so far before we introduce the new things. So our scenario number 2 that we also studied was the following. Suppose we have, okay, let me take population. So I'm not going to take money because I don't want money to decrease. So suppose that t equal to 0, the population in a certain town, let us say, is 5,000. Okay, and it was decreasing. So we have a decay by, let us say, 6% per year. So people are basically, sorry, when you guys don't see something, let me know. So it's decreasing by 6% per year. So the question is, find f of t, population after t years. So the population is really declining. People are leaving the town, there are no jobs. So population after t years. That's again a typical exponential decay. So here f of t will be 5,000 times b to the t. And let us see what b is. Since we have a decay, it means the growth rate is a negative growth rate. It's minus because we have a negative rate. Things are decreasing. Minus 6% means minus 6 over 100 minus 0.06. And b is 1 minus that. So every time the b represents what's happening every year. Every year 6% are gone. So the b is what's left, which is the 94%. Or if we do the math, we're going to get 0.94. So basically the b represents what's the percent which remain. 94% remain because 6 is gone. So this will be 5,000 times 0.94. Again, this scenario doesn't land itself into linear. It means it's not the same amount every year. So graphically, so we have to fully understand basically linear versus exponential, which is going to slowly we're building it up. So this is my population, which is starting at 5,000. And then after 1 year, there is a decay. So after 1 year, the population is going to decrease by 6% of 5,000. That's what's happening after a year. So 94% remain. So 6% of 5,000, it's 300. So my population is right here. So it lost 300. So now my population is, I don't know, 5,000, 4,700. A year later, it's going to decrease, but now it's going to decrease over a lesser amount. So now we're going to take 6% of the 4,700. So that's really how it is working. So we're going to take is 6% of a lesser amount, which is almost equal, again, I pick up my calculator to compute all this, 282, because it's 6%, we already lost 300, so we have less, now 6% of a lesser amount, which is 282. And now we can basically connect the dot, definitely not linear, and that's absolutely not linear, that's exponential. All right, so that's really what we saw so far. Okay, that's the piece we talked about prior to the test. Now what we're going to do today. Today we're going to do the following. Let us say, please ask question as I move on. Okay, let us say I have a population. So that's what we're going to do today. Suppose I have a population, for example. Okay, and I know that the growth, and let us assume it's growing. And I know it's growing exponentially in the sense that it's growing by the same percent every year. So every year it's growing by a certain percent. But I don't know the percent. I have no idea what it is. But what I know is 2 data points. So suppose I know that initially we have the value, and let us say I know after 2 years how many people I have. And I know that it is exponential. So I have 2 data points. I know it's exponential. And the question is, okay, can I find the rate? Or can I find a formula for the function, which will allow me to find the rate? So my question today is going to be a little bit different. I know that I have an exponential growth. I don't know the percent. I have no idea what it is, but I have 2 data points. So I know, for example, we're going to initial, and I know another data point. I know how much we have after 2 years. And the question is, can I find a formula for the exponential function? And that will be what we are going to talking about today. Right? So questions before I proceed. Okay. So today we're going, the idea is find a formula, how to find a formula. So how to find a formula for an exponential function from 2 data point for an exponential function from 2 data points. Means I have 2 values. How can I find a formula? Okay. Now, before we do it, if I had a linear function, it means if I have a function whose graph is a line, we answered this question. So if I have a line and I have 2 points on the line, we developed a way to find the equation of the line. Actually, I'm going to be doing the same now, but if I have an exponential and I have 2 points, how can I find the formula for the exponential? So it's really something very similar to what we've done before. And we will do that by example. So example number 1. Okay. Right, let f of x be an exponential function. It means the formula is a times b to the x. Okay, right. Be an exponential function. And I'm going to give you some data point, and you're given the following. So you're given the following table, where the table contains some value of x. So x, f of x, and you're given that if x is 0, f is 3. So you're given this data point. If x is 2, f of x is 12. Means basically you're given the following information. You have an exponential, means the graph, and the function is increasing because from 0 to 2 it increased. So basically we have an exponential, that's the graph of it so far. Okay. And we have 2 points. At 0, it's a 3, and at 2, it's 12. So I have those 2 data points. So that's my function n. The question is find a formula for f. for f of x. All right, so let us do it. I do the first problem, and then you guys will do the second one. All right. First, it's exponential. Exponential tells me that the formula is a times b to the x. Okay? It's linear. We know that's mx plus b. Exponential ab to the x. Finding a formula means we need to find the a and the b. That's really what we need to find. It's like for linear. We find the slope and we find the b. Here I need to find a and we find b. And I have those two data points. Let us understand what those tells me. Okay, let's understand. This table tells me that my function is going to take at 0 the value 3, and my function is going to take at 2 the value 12. Okay, and I'm going to use those two given to find the a and the b. All right, let us analyze. So I will do the first one very slowly myself. If my function takes 0 to 3, what does it mean? It means it's, if I plug in 0 for x here, I should get 3. So watch how I'm going to write this. It means a times b to the 0 is equal to 3. Okay, I plug in 0 for x. Now b to the 0 is 1. This gives me a equal to 3. So I was able to find my a. My goal here is to find the a and the b. Now, because I'm given the initial value, I pick up my a immediately. Now I'm going to use the second one to find b squared. So f of 2 equal to 12. It means, watch how I'm writing. It means if I plug in 2 for x, I should get a 12. If I plug in 2 for x here, I should get a 12. Can I solve for b using what's given? I want to start asking 2 questions, so you guys with me. Can I use this to solve for b? What do you think?
Yes.
Okay,
You
how?
can if you
Speak up.
You can if you put in the 3 for a.
Okay. ab squared equal to, but a is 3, is absolutely correct. So it means that 3 times b squared is equal to 12. Now I know I want my b squared, so I divide by 3 both sides. So divide by 3 to pull out the b squared. It's going to give me a 4. And now I need to solve for b. It means b is the square root of 4. It means b is equal to 2. So the goal here is, we want to find, we write the formula for the function, that's exponential. We need to find the a and the b. So to find the a and b, basically you think about it that you have 2 unknowns, a and b. And the problem should give you 2 equations to be able to solve for them. And the problem did give you. It gave you f of 0, which give me the first relationship between the a and b, and it give me f of 2, which give me the second relationship. And now my problem is to use those 2 equations to solve for a and b. In this scenario, the first equation gave me a automatically. To find the b, okay, I know my a, then I can find my b. So the formula here of f of x is going to be 3, that's my a, b is 2 to the power x. Okay. So this is the function that's exponential because it has the form ab to the x that satisfies those 2 properties. It means this function, so let me check. We're going to check. What do I mean by check? Okay. It means does this function that I find its formula satisfy those 2 conditions? If it does, it means I am in a good shape. If it doesn't, it means I'm doing something wrong. So let me check. According to me, if I plug in 0 here, I get 3. So the first property is satisfied. And if I plug in 2, according to me, I'm getting 3 times 2 squared, which is equal to 12. It means my formula matches those two data points. Right. I'm going to give you another problem along the same line, basically verbatim, and I would like you to do it. I'll give you a few minutes to do that. So question is, and then I'll ask you what you got. So question is, find a formula. So example number 2. Find a formula for an exponential function f of x, for an exponential function f of x, using the following data point, using the following table. It means I'm going to give you two values and you have to give me following table. Again, I'm going to make this problem. Okay, so let me see what I want. At 0, 900, and at 4, let us say 90. That's my function. So before you guys get started, let me analyze it. It's exponential. It means this function is going to basically not curve. And is it increasing or decreasing? Watch the graph. At 0, I am at 900. At 4, I am at 90. So we're really going down a lot. So this is going to be a decay, and it's going to be an exponential function that decreases. Now I want a formula for it. I'll give you 2 minutes to interact with it and see what you guys come up with, and put your answers on chat. Okay, get going. Otherwise, you will be bored just listening to me. Okay, I'm going to ask one of you to give me the answer, and those who find it, put it on chat so see what you guys are doing. Okay, if you guys find anything, please put on chat so I have an idea what's really going on. Okay, I'm getting 900, that's correct. B is 0.562. All right, I want more answers to see if she's right. I want somebody else. Anybody have the same answer as Sage or anything different? When I checked, it was a little bit off, but rounded up to 90. Yeah, that's okay because we are a little bit approximating. So it's all right if it's not exactly. Please, anybody else got anything close to Sage? Right, so I'm gonna pick somebody and tell me what you guys, what the student is doing. All right, so since I know Sage, what she's doing, so I'm gonna pick Xavier, are you with me?
Yes.
Okay, what did you do? Just tell me what you're doing.
So basically, first I set up the formula.
Yeah.
F of x equals a times b to the x.
Exactly.
And I plugged in the a, which was 900. And I knew that was the a because at f of 0, I got 900.
Right, so absolutely correct, because that's the A, because basically if you plug it into the formula, this is 900, the B is 1, A is 900. So that's the initial value. All right, keep going, Xavier.
And then in order to find the b, you need to set up the formula like f of x equals 900 times b to the fourth.
Wait,
And
you
then
lost me now. You lost me. What did you do?
I set up the formula
What
to
is it?
f of x equals 900,
No,
or
f of 0 is
4.
900. F of 4
Yeah, f of
equal
4 equals 900 times b to the fourth.
no. Wait, f of 4 is 90.
Mm-hmm.
Okay, and then you wrote 900 times b to which power?
4
Equal.
equals 90.
Right. All right, keep going.
Then I divided both sides by 900.
Right, you want to isolate the b to the 4.
And
So this gives me how much?
this gives you a 0.562341.
No, not yet. B to the 4 is b to the 4, and then you go to the b. So b to the 4 is 1 over 10. Am I right?
Mm-hmm.
Okay,
Yeah.
then b is what?
Then b will equal 0.562.
How did you get that? You're absolutely correct, but I'm trying to be slower.
I just used my calculator.
Yeah, but you did the 4th root.
Yeah.
Okay, so b is the 4th root. So that's b to the 4 is 1 over 10. B is the 4th root, which is, how much did you get? Give me three decimal places.
0.562.
0.562. Right, so now I have my b and I have my a. So my function will have the following form: 900 times 0.562 to the power x. Okay. All right, now Sage, she was checking her answer. So Sage was absolutely correct in her answers. And we're gonna check if we really, so that's a typical exponential. So we're gonna plug in 0. Of course, we got 900 because that's the easy part. Now I'm going to plug in 4. And we may be off a little bit, but we should not be off a lot. So we should get 90. But a little bit off because we are rounding. So I'm going to take 900. So I'm just checking that my formula fits the data to the power 4. And then I will do exactly, I'm going to pick my calculator. I'm going to compute 900 times 0.562 to the power 4. I'm getting 89.78. The reason I'm not getting 90, because as you realize, we rounded this a little bit. So this is almost 90. The reason we're not getting it exact is because we rounded to 3 decimal. If I had taken more decimal, I will get closer and closer to 90. All right. Part 2 is the following. In this problem, I gave you 2 data points, but I gave you basically the A for free. The second problem we're going to do is the following. What if I did not give you A for free? It means I did not give you the value at 0. I gave you the value, for example, at 1 and at 4. And the question is how to find the A and the B. So problem number 2. Just the same ideas, but I'm not going to give you the A for free this time. We're going to find the A. So I start example number 3. And this one you have to listen carefully, because once you learn the pattern, you will be able to do it. So the question is, some values of an exponential functions are given. Okay, some value of an exponential are given. Find a formula of an exponential function f of x are given. Find a formula for f. Okay, so again, I'm going to give you that. So this is my function. This is my x. This is my f of x. As I said, instead of giving q the initial, I won't give you the initial. So this is the 3. And suppose 3 is 12. So now I have my exponential function, which is increasing because, and I have 2 points. So at 1, the output is 3. And at 3, the output is 12, somewhere in here, let us assume. And my function is like that. It's curving. It's absolutely curving. It's an exponential. And usually it will go, we will discuss this next time, it will go like that for the negative values. And the question is, find a formula. So be very careful. I did not give you the initial value in this problem. All right. Okay. So let's see how we're going to do this. So f of x is exponential. It means it has the form a times b to the x. I need to find a and b. So I have 2 unknowns, a and b. I need to find them. Okay, what do I say? To find a and b, because they are 2 unknowns, they have to give me, I need to relate 2 equations that relate them. So the first one is, I have f of 1 is equal to 3. And I have another data point. I have to use both of them to find a and b. Now let us read the first. F of 1 equal to 3 means, if I plug in 1 for x, I get a 3. That's a 1 here. But let's pay attention that in this scenario, I'm not getting a for free at all. So because it's to the power 1. The second one tells me that if you plug in 3 for x, x is an exponent, I get 12. Okay. And now the problem is I have those 2 equations relating a and b. And the question is how to find a, b. So I have 2 equations and I need to use them to solve for a and b. So how can I do that? And so I will do this first problem. There are 2 ways of doing it. I will do it in the way that I think is a bit easier. So the way we're going to do it is the following. So I have really 2 unknowns, but I have enough 2 equations to find them. So this is the trick that we can use. We're going to do the following. I'm going to divide this by that. So watch carefully what I'm going to do. I'm going to divide. I take the one with the highest exponent on the top. I say this divided by that equal. A times b to the 3 is 12 divided by 3. So I just divided them. The one with the highest exponent on the top over AB. Now a to b to the 3 is 12 divided by 3. That's the main trick. Why did I do this trick and what's the benefit of doing it? Okay, I want you to look at it carefully and tell me what's the benefit of doing this division, so you understand why we do it. You should be able to answer the question. What do you think the benefit is going to be? Go ahead, Sage, Kale, Olivia. What do you think is going to be the benefit? I mean, I know I want to solve for A and B. What do you think is the benefit here is? Okay. This is AB to the 3 divided by A. The benefit is now I can simplify the A's. By simplifying the A's, I'm going to have B to the 3 over B equal to 4. It means I'm trying to get an equation in B alone. So the benefit of dividing them is basically to be able to simplify by A. By the simplifying by A, I have B to the 3 over 4. And now this is the question. B to the 3 over B is what? B to the 3 over B is what? What's B to the 3? It's B times B times B over B. So B to the 3 over B is actually B squared. Okay, so it's B times B times B squared. So it's going to give me that B squared is equal to 4. And now if B squared equal to 4, my B is equal to 2. And I will get the B. So the benefit of doing this division is basically to be able to isolate the B, because the division will help me to simplify. Once I isolate my B, then I can get B equal to 2. Now I need to find the A. How to find the A? Once I have my B, I have two equations. I can use either one of them to find the A. I can use either the first or the second. I usually try to use the easiest one. So to find A, we say that we know A times B is equal to 3. That's this equation right here. That's the one I am using. Okay, so I use one of the data I have to find B, but B is 2. So I get A times 2 is equal to 3. And now I solve for A, which is going to give me 3 over 2. And now the formula will become f of x equal A, which is 3/2, times the 2 to the power x. And this will be the formula for the exponential function that will fit my data. Now let me check here on the side. Okay, I'm going to check. It means, does this function satisfy both conditions? Does it take 1 to 3, and does it take 3 to 12? So at this stage, I'm just checking to make sure my formula makes sense. All right, so if I plug in 1 in it, I get 3 over 2 times 2, which is a 3. That's correct. If I plug in 3 in it, I would get 3 over 2 times 2 to the power 3. It means 3 over 2 times 8, which gives me 24 over 2, which is equal to 12. So my formula fits exactly the data that's given to me. So that's the right formula. So again, let us a little bit summarize how we solve those problems when, when we don't have the initial value. The main trick is to divide one equation by the other. The benefit of doing this is to simplify the A. Once I simplify the A, I can get an equation in B alone. I can solve for B, and then I say, okay, now I have B. Then I can use either equation to solve for the A, and I have my formula. So before I give you another problem for you to practice, I need to talk a comment about dividing exponents. Okay. So this is dividing and multiplying exponent. So I'm gonna just take a kind of exponent. Okay, so I'm gonna a little bit gear away move a little bit away from the section for like 2 minutes, and then I will go back. So my question is the following. Suppose I have 2 to the power 3 times 2 to the power 4. Okay, my question to you, this gives me 2 to which power? And think about it in the most logical possible way. Peyton, 2 to which power? The most logical. You don't memorize anything. Just think about it. 2 to the power 3 is how many 2's? 2 to the power 4 is how many of them? 4 of them. 3 of them and 4 of them. So 2 to the 4 times 2 to the 3 times 2 to the 4 is going to give me 2 to how many power? 3 from here and 4 from here, 2 to the power 7. It means that if you have a number, any number, a to the n, you multiply it by a to the m. What you do is you're going to add the power, n plus n. Now I'm going to ask you the following question. Suppose I have 2 to the power 8 and I divide it by 2 to the power 2. I'm going to get 2 to which power? And what's the rule? Think about it the same way I thought about it in this problem, by expanding and see what's going to be the rule. Please give me the answer on chat. Tell me how much I should put inside the box, and then what's going to be the rule. Okay, Matt Trimmer. Matt, are you with us? Matt? Okay. Maddie Major. Maddie, are you with us? Maddie? All right, Maddie is not there. Okay. Peyton, are you with me? Peyton, are you with me? Yes or no? Can you hear? No, I don't hear anything. No. Two to the power 4. Why 2 to the power 4? Why 2 to the power 4? If you expand it, I want you to expand. 2 to the power 8 is how many 2's you have? 2 times 2 times 2 times 2. 1, 2, 3, 4, 5, 6, 7, 8, right? And divided by 2 squared, it means 2 2's. How many 2's we will have? So I have 8 of them. 1, 2, 3, 4, 5, 6, 7, 8 over 2 times 2. I'm going to have 2 to which power? I'm not going to memorize. I will tell, yeah, it's 2 to the power 6. This 2 and this 2, I have 8. This 2 and this 2 will go. So what I'm going to be left with, actually 2 to the 6. Okay, so we have 2 to the 8 up here, divided by 2 squared is 2 to the 6. So the 6 represent what? It's basically the 8 minus the 2. It's the 8 minus the 2, because that's the picture. We have 8 of them, we have 2 of them. We simplify 2, we're left with 8 minus 2, 2 to the 6. So this tells me, in general, if you have a to the n, and you divide it, so it's the same a, but you divide it, what you get is a n minus m. You subtract the power away. Okay. So, for example, we're going to do those quickly. 2 to the 7 over 2 to the power 3 is 2 to the power 7 minus 3, 2 to the power 4. And if we think about it in those terms, I have 7 2's divided by 3 2's. I'm left with 4 2's. And we can keep going along the same line. So these are important property for the exponent that we're going to use in this section. Okay. Now I'm going to give you the following problem. Okay. Some values of an exponential function is given. So some values of function f of x is given. Find a formula for f of x. F of x. Okay. So I'm going to give you this is x, this is f of x. And at 2, so I'm not giving you the initial value. At 2, the function takes the value 4. And let us see, at 5, the function takes the value 13.5. So if I'm plotting those points, if x is 2, my function takes the value 4. So that's a point here, 2, 4. At 5, so 2, 4, 5 right here. So that's my 4, it's 13. So this is my second point. So this is the function I'm working with. And the question, find a formula for f. Okay, so again, I will give you a little bit to interact with the problem, and then I will work with you. The minute, if any of you find answers, please write them on chat. Who would like to help us all do it together? Who would like to lead the problem? Anybody is ready to lead? Okay, I'll pick a student, and if they feel comfortable, they let me know. Nick, are you ready to lead? Nick? Right? Sage, are you ready to lead the problem? Sage?
Yes.
Okay, are you ready to lead?
I was in the bathroom just a second ago. I'm sorry.
Okay, anybody can give Sage a break? Taylor?
I'm not sure.
You're not sure? All right, so what?
Sorry. Am I just setting up the problem?
Yeah, I want you to find A and B.
Oh, wouldn't you do a times b to the 5th equals 13.5, and then you divide it by a times b to the 2nd equals 4?
So we're using f of 2 equal to 4. Means a times b 2 equal to 4. And the other one?
Which is, yep.
It gives me what?
A times b to the 5th equals 13.5.
Right. First we set it up, and then you want to go after A and B. What do we do quickly?
You would put the one with the higher exponent on top, divided by the other one.
What's the
fraction.
benefit of that?
Just easier simplifying.
It helped me to do what? Get rid of what?
Get rid of the A's and the remaining of the two B's.
So now what this will give me?
B to the third equals 13.5 over 4.
Right?
And then you square root it by 3.
Uh-oh. No,
Or
we don't
both sides.
call it, no, we don't call it square rooted. What do we
Oh,
call
sorry.
it? What do you call it? Cubic root.
Cubic
Yeah,
root.
it's crucial.
Sorry.
Very good. Yeah, no problem. Then we get B is the cubic root of 4. All right, did you do the math here?
Not yet.
Okay.
I know it's going to be a very weird fraction.
No,
though.
I don't think so. I think I picked this one to be nice. Anybody else? Do the math here. Some answer will be weird. Yeah, but this one I think it's not. Anybody got the answer to this one? Okay, I will do it. So we have 13.5 divided by 4, and the cubic root, it means to the power a third. Okay, I'm getting 1.5. Okay, so B is 1.5. So now I get my B. Now we need to find A. Okay. Now to find A, I have a choice. Either I use this data point or I can choose that data point. Either one will do. So I can use the first data point. So we're going to use the fact A B squared equal to 4. Okay, to find the A. So it means that A times B squared is 1.5 squared equal to 4. So this means that A times, now 1.5 squared, we can evaluate it. So if I do that squared, I'm getting 2.225 equal to 4. Now I solve for my A, which is 4 divided by 2.25. And then we try to compute that number. And this is a little bit weird. So we're going to basically round it up, 1.78. And finally, my function will have the form 1.78 times 1.5 to the power x. Okay, and that's really the form. Now we can check that it fits our data like I've been doing in the previous problem. Now, the last question we're going to do is what we started with. Suppose I have a population, and I'm going to tell you that the population is growing exponentially, but I will not give you the growth rate. I'm going to give you 2 data points for the population. And the question is, find a formula and then find the rate. So this is my problem. So example. So at t equal to 0, the population is in a certain town is 5,000. So I'm giving to the population. After 4 years, with t equal to 4, the population is declining, let us say. The population decreased to 2048. Okay, so we have an absolute decay. And that's going to assume, so the population is decreasing exponentially. Is decreasing exponentially. Okay, so the population was at 5,000. After 4 years, it went down to 2024, and it is a decreasing exponentially. So it's not linear. It doesn't grow by the same amount. So let f of t be the population after t years. F of t population after t years. So question number A is find, so we're going to have several two parts, find a formula for the population. For f of t. Okay, so this time we know it's exponential, but I don't know the rate. The only thing I have is two data points. I know this is for 2048, and this is the initial population, but I don't know at all by which rate it is decreasing. I want a formula for f of t. All right, so I say, all right, since it's an exponential, it means the formula, the function have the form a times b to the t. Okay. And now to find the formula, I need a and b. Now what's given? Initially, we have 5,000. So that means that a is 5,000. Now, I'm giving you that after 4 years, the population decayed to 2048. It means that a times b to the 4 equal 2048. So, but a is 5,000. But a is 5,000. So this tells me that 5,000 times b to the power 4 is 2048. And now I need to solve for b. So this will give me b to the power 4 equal. I divide by 5,000, both sides, and then I want to solve for b. So it means that b is the fourth root of that. So that's a scenario where I have data point. I know it's exponential. I have data, but I want to know basically more how the population is changing. So let me see b equal to. So again, I have to plug in those numbers because I didn't. So that's 2048 divided by 5,000. And we're going to use it out to the power 1/4 because I need the fourth root. So I'm getting 0.8. So it means that the population is given by the formula 5,000 times 0.8 to the power t. So here I have data and I'm using the data, and I know that the decay is exponential. I'm using the data to find a formula for the population. Now question number B is find the growth rate. Okay, what's the growth rate in this problem? Now that I find a formula, what's the growth rate? This population is decreasing by what percentage every year? So this population is decreasing. What's the percent by which it's decreasing? So that's 5,000.8. Remember here the growth factor is 0.8. That's the B. So what's the growth rate? By 20%. Absolutely correct. So it means that this is a population. It's something that I didn't know before. Now that I find the formula, it's a population that's decreasing by 20% per year. So once I have a formula, I know what's really going on with the population. So find the growth rate. We know that 1 plus the growth rate is 0.8. So if we didn't see 20%, it means the growth rate is 0.8 minus 1. It means minus 0.2. It's a negative because we have a negative growth. The population is decreasing. It means minus 20%. Okay, so this is a population that's decreasing at a rate of minus 20%. Question before I move on. Right now, what we are going to be talking about is exponential versus linear. So we've studied two types of function, exponential and linear. And we're going to try to compare them to both. So exponential function functions compared to linear. Okay. Let's see what's really going on. First, linear, it means they grew by the same amount every year. That's one distinction. Exponential, they actually grow by the same percent. That's what we know so far. But when we're going to emphasize this idea a little bit more. So let us recall linear, a little bit linear. So suppose I have the following function, f of x equal 4 plus 5x. So what I'm going to do now, what we're going to do is compare linear to exponential. So let me start with the linear and let us remind us. Here, the slope is 5, and the initial value, b, is 4. So if I take this function and I graph it, okay. So I know that we know this stuff, but I need to emphasize the difference between linear and exponential. Let's see how linear works. We start with x, and this is f of x. At 0, so this is 5 plus 4x, or 4 plus 5x. At 0, the function takes the value 0. Now, after 1 unit, what will happen to the function? After 1 unit, if the slope is 5, what we're going to have is that's equal to 9. It means after 1 unit, we add, so from here to here, and then we're going to add 5, which is the slope. So we start at 4. After 1 unit, so we go to the left, we're going to go up by 5. That's one value. Now, after 2 units, again, 1 more unit, that's a linear growth, we go up by another 5. The same amount. And when we connect them, because we're going by the same amount every unit, we get a straight line. So after 2, we have 14, means from here to here, I'm adding a 5. Addition is important in this. And from here to here, so we go by 1, we went by 5. We go by 1, we go by 5. And if we go by 1, we're going to go from here to here by 5, which is going to give me the 19. So in a linear setting, when the x value, the linear setting, when x increases by 1, every time x increases by 1, then 5 is added to the y value. Okay. So in a linear situation, okay, in a linear, whenever the input increases by 1, 5, the output increases by 5. So in general, we have the following for linear, which is again a recall of what we do. So in general, if f of x equal mx plus b, then when x increases by 1, then the y value increases or decreases by m. That is, m is added to the y value. So graphically, that's how linear work. Whenever we start, when x increases by 1, m is added to the y value. It's the same amount. By 1, m is added. And that's really linearity. Now I want to compare this with the exponential growth. What happened in the exponential? So linear, we add 1, x increased by 1, the output increased by the slope. Now we have to contrast this with the exponential function. What happened in the exponential? So we elaborate by an example, and then I will take the rule. So exponential. Let's see what goes on. Suppose I take the following function. F of x equal 4 times 5 to the x. Okay. So in this scenario, my A is 4. My B, my growth factor, is 5. Now let's understand a little bit more the growth factor. Why is called a factor, and what does it represent in terms of the function? A little bit more. This is my x. It's my f of x, which is 4 times 5 to the x. At 0, I plug in 0, I get a 4, which is the initial value. At 1, what do I get? 4 multiplied by 5. So when x increases by 1, what happened here to the output? I'm not going to substitute 4 by 5 by 20 because I know it's 20. What do you think happened here? What did we do? From here to here, what happened to the output? How can I get 4 times 5 out? We multiplied the output. This is multiplied by 5. So we're actually multiplying by 5. That's in the exponential. That's really why the word factor is coming from. We're multiplying by a factor of 5. Now, we add one more. If x is 2, it's 4 times 5 squared. It means 4 times 5 times another 5. So from here to here, again, we multiplied by 5. And I can keep going. So the linear, we're adding 5 each time. In the exponential, we're multiplying by 5. So if we add one more here, 4 times 5 to the power 3, again, my output is multiplied by 5 again. So when x increases, when x, the input, increases by 1, the y value, that's in an exponential, is multiplied by 5. So in a linear growth, when x increased by 1, we add the slope. We're adding the slope. In exponential, we multiply by 5. That's why I call it factor. It's the factor that we multiply by when x increases by 1. And that's really what's happening in an exponential. So in general, we have the following. If f of x is an exponential function, b to the x means the growth factor is b. The growth factor. Then, when x increases by 1, the y value is multiplied, not added, is multiplied by the growth factor B. So that's my picture here. This is x, a times b to the x. 0, 1, 2, 3. X increases by 1. This is a. This is a times b. We multiply by b. 2 increases by 1. This is a b squared. We multiply by b. So every time my x is increasing by 1, my y is multiplied by b. So that's the, in terms of value, that's really what's happening in the exponential function. Okay. So now I'm going to do a practice for that. And next time we'll do more practice. So I'm going to do the following. I'm going to give you the graph of a linear function and a exponential. And I'm going to give you an unknown k, and I'm going to ask you find k. So the question is the following. Each of the graph below is either linear or exponential. Linear or exponential. Okay, the question is find k, determine k, without finding a formula for the function. For the function. So let's see what I am talking about. So I'm going to give you two graphs. And I'm going to give you a bunch of points. So this is my first graph. I'm going to give you the point here, x, f of x, and 1, 2, 3, 2, 4, okay. And this is my graph. So my points are 1, 2, 2, 4, 3, okay. Okay, my question is, without basically finding a form or anything, what's the k in this problem? Very quickly. So that's linear function. What's going to be the k? 6. We go by 1. We're going from here to here by 2. So if we go by 1, we're going to go by 2. So my k is going to be the 4 plus 2, which is equal to 6. Now, suppose I give you the same thing, the same value, but I'm going to make the function exponential. It means, suppose I have that. That's x. I'm going to call this is g. And 1, it's 2. 2, 4, 3, okay. But now this time, my function is like this. This is 1, 2. So 1, 2. This is 2, 4. But my function is not linear. It's exponential. And this is 1, 2. And this is 3, k. What is k in this scenario? What's k in this scenario? So that's an exponential function. How does it behave? Increase by 1. Exponential means that the output will be multiplied by the same amount. So from here to here, so that's exponential. Means when x increased by 1, the output is multiplied by 1. So this is from here to here, we know it. It's multiplied by 2. Being exponential, it means from here to here, we should also multiply it by 2. So what does it mean? It means that k is going to be equal. Why 16, Esmeralda? We have to multiply by 2. From here to here, we multiply by what?
I was thinking like squaring it.
No.
Instead of like actually multiplying. Yeah.
Multiply. So if you multiply it by 2, the exponential, it means you keep multiplying by 2. So my k is going to be 4 times 2. My k is going to be equal to 8. Okay, so that's the main difference, important difference between linear and exponential. Linear, we grow by the same amount. You're adding here the 2. You add the 2 as you increase by 1. Here, it's not. From here to here, from 2 to 4, you multiply by 2. So you have the 4. From here to here, you're going to multiply by 2. So if you had a 4, you multiply by 2, you're going to have an 8. So it's a very different behavior. The linear and exponential behave in a very, very different way. Right. Okay, definitely. I'm going to stop at this stage. Please do the homework. We still have quite a bit to talk about before the end of the semester. Please do the homework for next time. It's crucial. Okay. If anybody has any questions, I can stay. Otherwise, the class is dismissed.
Do we have any Moodle?
Thursday, not today. Now I want you to do the homework. All right, please do the homework.
It'll be assigned Thursday to be due Thursday next week.
Yeah. I have to look what they have. Thursday I will talk about Moodle. Okay, now do the homework for next time. It's crucial. Okay.
Also, this isn't